CompTIA IT Fundamentals Plus, Module 4, Unit 1, Networking Concepts. At the end of this lesson, you should be able to describe the components and functions of computer networks, list the protocols and technologies used for addressing on computer networks, connect a computer to a wired or a wireless network, and describe the uses of common application protocols. These are the kind of main components of a computer network. A lot of the other pieces that we'll talk about here will be related to any one of these concepts. The concept of the client-server network, where you have clients and servers, local area network or LAN, which is a network in, let's say, in a single building, and the wide area network, which is a network that spreads in multiple buildings, multiple cities, and even the internet is considered the WAN, which is a network of networks all over the world. When it comes to network media, these are some of the concepts that we're going to be talking about. Nodes or hosts, which is basically any device on the network. Wired data connections, copper cabling, fiber optic cabling. Ethernet is one of the most common type of media that we will going to be discussing. Wireless or Wi-Fi data connections. WAN links, such as fiber optic cabling, point-to-point radio, cellular radio, and satellite. So what is a WAN? Again, a WAN is a wide area network, and basically what it does is it connects sites in different geographic. The concept of addressing and protocol is extremely important in networking. So we're going to be looking at the standards and protocols, the standards that they provide, the format for computers to exchange data over the network using frames and packets. So basically, you could say that these protocols are kind of like the language of computers, how they communicate with each other. And again, those protocols have to be formatted in a specific, format and standard. Addresses to identify interfaces. So every device that connects to a network has an interface, and that interface has an address, which is called the MAC address, and then that MAC address is tied to what is called a logical address or an IP address that we will be discussing. But again, so network frames and packets have headers and payload. So when you send a network packet, when you send something, an email or whatever, there is a header that have information about the source and the destination IP address, and then the actual content of the packet. Think of it as an envelope when you send a letter. There is information of who's sending, where it's going, and the actual letter inside the envelope. Network media standards include Ethernet. We're going to be talking a lot about Ethernet, and Ethernet could be either wire or cable links or Wi-Fi. Most local area networks and the internet use TCP/IP and IP addressing. So basically, TCP/IP IP addressing is the protocol of the internet. Anyone that connects to the internet needs to use an IP address. When it comes to TCP/IP and packet transmission, we have what are called the Transmission Control Protocol or Internet Protocol, referred to as TCP/IP. And then we have packet transmission versus circuit-based networks. And what that means is that communications is broken into small packets, multiple paths between network nodes. So if something happens, if you look at those nodes over there, if a host is sending data, and while the data is in transit, there are many connections in its way. If something happens to one of those nodes, then the packet can be rerouted to another path. And the devices that are in charge of this routing are called routers. And routers, typically the way they work is that they choose the best available path. When a packet is lost or damaged, then that packet is resent over the network. So what is a packet made of, right? A packet consists of a number of fields contained within a header section plus a payload. So the two main sections are the header and the payload. There are others, but those are the important things to remember. And basically the payload could be a packet from the protocol layer above. So let's say you send an email. There is information about the source and the destination address, and then the actual content of the email. Could be just text, or it could be an attachment. Well, that's the payload. So what are the key features of a packet switching network? Nodes within the network can perform a forwarding function, which basically allow packets to utilize many available paths through the network. This makes the network robust against link failures, so that if one of those links fails, then the packet can be rerouted. And also this is beneficial for the network to use a small packet. So that's why packets are broken into little pieces, and then again each piece of that packet could be sent through different path. There are four protocols in the TCP/IP protocol suite, or four layers. So the application layer, the transport layer, the internet layer, and the link or network interface layer. And from this is from top to bottom. First, you have the protocols, the applications, whether that is DHCP, BootP, DNS, you name it. For example, HTTP. So when you open a web browser and you go to google.com, you actually, that web page you use in HTTP. So that's the application. It's important to clarify here that application doesn't mean like like Microsoft Word or Excel, something like that. We're talking about web applications, right? When it comes to transport, the two protocols here are TCP and UDP. TCP is the it's a connection oriented protocol, and UDP is a connectionless protocol. And think of the transport as the delivery mechanism. Let's say that you are moving goods in a truck from one place to another. So transport would be the truck in this case would be the transport, either TCP or UDP. Internet, has to do with stuff like the IP, ICMP, and RP are part of this layer also. And the important things to remember here is the IP is the internet protocol, and this has to do with the logical address. Every host, every server on the internet needs to have an IP address, and this layer has to do with that. And there's all the protocols there that we will discuss, like ICMP and RP, but IP is the big one here. The link or the network interface, which is the bottom of the protocol suite, has to do with protocols like PPP, PPTP, and again we'll discuss those a little more detail. But it also has to do with the actual interface itself. It could be either wired or Wi-Fi, and this is referred to as Ethernet. We will talking about this. So the link or network interface layer has to do with the stuff like the Ethernet, Wi-Fi or wired networks, the local network segment only of the network, so without going to another network. It handles also the frames. The internet layer or internet protocol IP, it's the main protocol in the TCP/IP suite, and basically this protocol is responsible for logical addressing and routing of packets between the host and the network. This is the protocol that has to do with IP addresses, which we will discuss in more details. The ARP, or the Address Resolution Protocol, is used for hardware address translation. In other words, if I know the MAC address, then from that I can get the if I know the IP address, I can know the MAC address. So the translation between the logical address and the MAC address, that's what this is about. And the MAC address is an address that every network card comes with from the manufacturer, and this is fixed, built into the network card. The Internet Controlled Message Protocol, ICMP, basically what it does is send messages and reports errors regarding packet delivery. So let's say that you want to see if there is communication between a client and a server. You can ping an IP address, and then you'll get either a reply back, or you'll get an error, depending on how it's configured, even though this is not all the time. But anyways, we will see this in action later on. Then we have the transport layer, and the transport layer, it's composed of either TCP or UDP. TCP provides connection-oriented delivery, while UDP provides connection-less delivery. And then finally, we have the application layer. So here we have from bottom to top. In the previous, we had it from top to bottom. Now, again, when it comes to the main protocol in the TCP/IP suite, which is IP, the fields important to remember here is the source IP address. So when you are doing anything on the internet or in any network, there is a source IP address, which in this case would be the source of your computer or device, whatever it is that you're doing. It basically identifies who the sender is. And then there is a destination IP address, which identifies the destination of the datagram of the IP address, right? So if you go to google.com, then google.com contains the server with the IP address that will deliver that web page back to the source address, in this case, whoever the sender was. And when it comes to a web page, you're using TCP. So if something happens while the page is loading and it fails, then you need to do it again, right? So the protocol then here, it's TCP. There's other technologies out there, like if you listen to broadcasts, listening to radios and stuff like that. There's a lot of other applications that use UDP, but most of, like, when you're browsing the web and downloading pages and files, then TCP is the protocol used. And there is another field called the checksum. And what this field does is basically it verifies that packages are integrity on arrival of the destination. If something happens and the packages are not, complete, if they are damaged, then they need to be resent. Another key concept of the IP protocol is the time to live, which basically is the number of seconds that a datagram is allowed to stay on the network before being discarded. So otherwise, packets could endlessly loop around the internet. So in other words, if something happens to a packet, it needs to be resent. And this is the job of the router. So the router will basically decrease the TTL by at least 1 second when it handles the packet. And if it cannot be delivered, you just get an error. But it won't just continue retrying on and on and on. So IP addresses comes in two flavors. There is the 32-bit binary value expressed in that decimal notation. So an IP address will look something like this: 172.10.15.12. We're going to be talking a lot about this in subsequent units. And then, so you have IPv4, that's an IPv4 IP address, and then IPv6, which is the newer version. They are 128-bit address, and there we will see over there a couple of tables how to convert from IP address to decimal and that kind of stuff. We're not going to worry about this for now. We'll do that later on. At this point, the important thing is to understand the concept that There are two flavors of IP addresses, the IPv4 and the IPv6, and you should be able to recognize when you see an IP address format, whether it is a IPv4 or IPv6. All right, so what protocol is usually used to provide logical addressing on a network? Again, logical addressing is the IP addressing, because remember, there is logical address or IP address, and there is the MAC or physical address, which and they are, they're related, but they are different. When it comes to networking, an IP address contains the network ID and the host address. The network ID, it's common to all hosts on the same network. The host ID identifies a host on a particular network. Think of this of a, let's say the zip code and the street address. The street address identifies it specifically where the mail it's going is the address of the person, but then you need a zip code that identifies the city and the section within that city exactly where that particular address resides. So we'll see that in more detail later on. The network prefix or subnet mask is used to identify the network portion within the IP address, and then the mask shows how many bits from the start of the address belong to the network ID. When it comes to packet delivery and forwarding, logical addressing or IP versus the local or MAC address interface. So the important things to remember is that behind the scene, when you are in a local area network like the one shown in this picture over here, the communication, it's actually done from one computer to another through the MAC address. And obviously that MAC address is translated into an IP address. That's the IP address that we basically work with. But now, obviously, when a packet needs to get out of the local area network, let's say when you send something to the internet, then the MAC address won't be used anymore, because that MAC address only exists or only works while you are within that local area network. And again, so that means that the packet needs to be handed to a router, and then that router will take that package to the next hop to go to outside the network. Important thing to remember here is that the MAC address is a 48-bit expressed in hexadecimal, and it looks like that number listed over there. So 00 column dot 60 dot 8c dot 12 column 38 column bc. So again, that's the format of the MAC address. The address resolution protocol, or ARP, basically what it does is identifies the MAC address associated with an IP address. So every MAC address is associated with an IP address. And the mechanism that we use to route or move packets from one network to another is called routing. So it's important to note that if the network ID of the destination IP address is different to the source, then the packet is sent to a router on the local segment, which is called the default gateway. And basically what the router does is that it forwards the packet to its destination, possibly via intermediate routers. So this usually, especially when you go to the internet, you're going to have many routers. First off is the router that you have in your house, and then that data is transmitted to your ISP, and then the ISP, we have many routers, and that once the data is delivered to the recipient network, in this case, let's say, if you're looking for google.com, well, google.com is a huge network with many routers as well. And again, so it's a very complex mechanism behind packet delivery and forwarding, but at this point, these are the concepts that we need to be familiar with. So what type of address identifies a network interface in the context of the local area network segment only? And again, this is a MAC address. as immediate access control, or MAC address, also called the physical address. So remember that we're going to be talking about two types of addresses: the logical IP address, which is the IP address, and the MAC address or physical address. What type of device is used to transfer packets between different networks? This is important to remember: a router. So the router is what actually transfer those packets. So when you go to google.com, you are in your local area network at home, your home network. The router has to work. The router then basically takes that package and delivers to the a key component of the internet and networking in general is the domain name system, or DNS. And so basically, IP and MAC addresses are very hard to remember. So imagine that every time that you needed to go to the internet, to a web page, you have to know the IP address, right? That would be impossible. Well, names are a lot simpler to remember. And because of that, then DNS was invented. So domain name system, or DNS, what it does is that it maps names to IP addresses. The DNS is basically a hierarchical distributed database that contains all of those domains. The root of the namespace, it's noted by a dot, and then you have top level domains referred to as TLD, such as .com, .edu, .org, and so forth. And then you have registered domains within the TLD. So what that means is that when a company needs to have presence online, if you need to have a website, you need to register that name with one of those registrar on the internet. And then basically this whole system of the net creates the host and the subdomains within a domain name. So we're going to have a discussion in more detail about this in future units. The host names and the fully qualified domain names, or FQDN, extremely important to understand this. So the host name is allocated to hosts, and the hosts are basically every single device on the internet, the computers and the servers in this case. It could be other devices. One thing important to remember is that up to 256 alphanumeric characters in hyphen. The host name cannot be longer than that. Usually they are much shorter. It would be really difficult to work with such long names. The host name plus the domain name plus the TLD suffix, it's basically what is called as the fully qualified domain name. So how does DNS work? In this DNS query example, so you have a client that basically it's requesting a web page. So you go to www.comptia.org. Again, underneath that URL, there is an IP address. Basically, what you do, you go to your local DNS server, which in this case, your router most of the time acts as a DNS device, a DNS server. If DNS is configured properly, the router then will send that query to other DNS server. If you have never visited the page, if you visited the page information may be cached locally on that server, on that router. But if not, then it'll go to the top level domain. The top level domain say, oh, it would say the server in charge of this domain is the .com domain, and then they hand it off to that domain. And then the .com domain say, oh, okay, the server that actually knows about that web page is the CompTIA.org DNS server, and then it hands it off to that server and so forth. And then finally you get that web page. So as you can see, there's a lot of pieces and components that. So which protocol allows people to use names and labels to address network resources rather than the numeric IP addresses? And again, the domain name system, or DNS. So every time that you go to facebook.com, you are using DNS. Now, what is the structure and format of the URL, or the Uniform Resource Locators? Well, first of all, if you look at the example at the bottom, first of all, you have the question. Which of the following parts of a web address is usually, or which of, actually there's a typo there, but which part of the web address usually depends on a name resolution service, protocol type, host location, and file path. And again, the host location is usually represented by a fully qualified domain name or FQDN. Two key technologies, two key components within the internet is HTTP and HTML. HTTP stands for Hypertext Transfer Protocol. These components are the basis of the World Wide Web. Basically, they enable clients, typically web browsers. So when we're talking about clients in terms of, in this context, we're talking about web browsers like Chrome, Firefox, Microsoft Edge. And what those browsers do is that you request resources from an HTTP server. In this case, if you go to google.com, it's a website, but underneath that website, there are multiple servers, many servers, right? So we got web service. Intranet is, most corporations have an intranet to hand resources for their employees. If you can access the internet, then it is referred to as an extranet. And then all those websites are composed of web pages, right? Which are the hypertext markup language behind those web pages. What does HTTP stand for? And again, so HTTP stands for the Hypertext Transfer Protocol. So the internet was not invented or created with security in mind. Actually, the whole concept of the original internet was to share knowledge, to share. It was actually created by the military so that in case there was a war, they have multiple paths of communications. But that's history. So to make the internet a little bit more secure, we use protocols such as SSL and TLS. SSL stands for the secure sockets layer, and TLS stands for the transport layer security. TLS is a more secure modern protocol than SSL, and that's what basically it's used nowadays. What they do is that they establish identity of website and protects communication between the server and the client using encryption. So if you go, let's say, to Amazon.com, any information that is sent between your computer at home and Amazon.com is encrypted because of these protocols. Site represents a digital certificate issued by a certificate authority. So there are companies out there whose job is just basically to issue the digital certificate to companies that need presence on the web. And then the client can choose to trust the certificate in CA. So clients such as those web browsers, they trust this well-known company that provides the certificate. But if the certificate is expired, or you go to a website that have a problem with the certificate, then you're going to see in Internet Explorer in Chrome, you're going to see a red X on the web address indicating that. And again, we'll discuss this and show this later. One of the oldest and most used technologies in corporations still nowadays is electronic email, or email, right? That we all use every day. Within email, the text messages are combined with attachments. This is referred to as the multi-purpose internet mail extensions, or MIME. So basically, when somebody's talking about, the MIME technology, we're talking about all these email messages and attachments and all that stuff. For sending messages, we use protocols such as SMTP and through Mail Exchanger, which is the service that route this message, that send these messages. For retrieving messages from a mailbox, we use protocols such as POP3, which is the Post Office Protocol version 3, or IMAP, which is the Internet Message Access Protocol. If you use in corporations, use one of the most used is Microsoft Exchange. Microsoft Exchange use SMTP. If you use a Gmail account, those servers use the most common protocol is IMAP, and all the companies over there, especially those web-based email addresses, use POP3. Now, if you have, let's say, a Gmail account, yeah, you can use the web Gmail, go to gmail.com, log in, and that's fine. But um, there are more, I would say, richer clients out there. Like, for example, Microsoft Outlook is a client that you can use to configure your email. For example, this is a screenshot of Microsoft Outlook, and this client is being configured to use that. So there's a lot more features. It's better to use using a web-based email address. It's clumsy sometimes. Personally, I can't stand it. I love Microsoft Outlook, and all my emails are configured this way. So we will talk about that and show how to do that. And question: which email protocols are used to download messages from a mail server? And again, the two protocols used here are POP3 and the IMAP protocol. Okay, so we have come to the conclusion of this unit. So what did we review here? We talked about the main components and functions of computer networks. We listed the protocols and technologies used for addressing on a computer network. We talked about, we didn't connect, but at least we talked about the different connections and the different media to connect either wire or wireless network. We'll discuss this in more detail later on. And we also talked about the uses of common applications used in networking. Thank you. And in the next unit, we will expand a little bit more.